Welcome back to Unit 9, Analytical Geometry, Grade 12 Mathematics under the CAPS syllabus. So today, we're going to focus on this analytical geometry, which is mainly focused on circle geometry. Then we're going to look also at line equations, right? We're going to look at tangents to a circle. We're going to look at the relationship between the gradient of a tangent and the gradient of a radius of a circle. So basically, you can see that looking at the picture on the right, we see a circle is the set of all points a fixed distance from its center. So you can see there are two types of circles here. There's this center circle with center AB, and there's this bigger circle in blue with center 0, 0. So the equation of a circle in general, it's y, it's x squared plus y squared is equal to r squared if the center is 0, 0. But if the center is not 0, 0, let's say for the green one, it will be x minus a in bracket squared plus y minus b in bracket squared is equals to r squared. In other words, the coordinate of the circle, center of the circle is AB, right? So if the center coordinate is 0, 0, then the equation transforms into that one. So in other words, it's x minus 0 squared plus y minus 0 squared is equal to r squared. So therefore it becomes y plus x squared is equal to r squared, which is this one. So this is what we are going to mainly discuss about on this in this chapter. So let's move on. Cartesian coordinates. So let's first start from the basics. It's something that you have already done in the previous chapters, but just for revision's sake, we just have to go through it again. So a point is written as xy, x representing the x coordinates and y represent the y coordinates, where x is the horizontal and y is the vertical, which means the horizontal and y is the vertical. So for example, point A 2, 3, it means we're going to x, where x is 2, then we go up, where y is 3. So the point where they meet here, that's the coordinate of A. This you've already done it, so I'm just gonna rush through it because it's something that is basic knowledge. So the x coordinate tells how far left or right the point lies, which means it's either left or right. So if it's on the positive side, in this case plus 3, you know, is 3 points from the center 0 here, right? Then the y coordinate tells how far up or down, so up or down, the point lies. So the origin, which is 0, 0, is where the x-is cross. So here, where the x is cross, so that's what we are talking about. Then error sketch helps prevent some error. So the exam habit is plot and label given points before using the formula. This will help you to visualize and contextualize the question. So that is an exam tip. So let's move on. So distance between 2 points. So distance is the length of the straight line segment joining 2 points, right? So if you've got point A and point B, so this line, that's what we call the straight line segment. So in this case, it means you'll be having coordinates. For example, here for A it's coordinate 1, 2, and for B it's coordinate 5, 5. So in this case, if you want to find the length of the line AB, so in this case it's written like this, right? This is your A and this is your B. So you can see, since it's a right angled triangle, you can also use what they call Pythagoras theorem. So where this is your C, your A, and your B, so it says A squared plus B squared is equals to C squared. So that is more like the Pythagoras theorem. So if you apply it there, it means, so since this is your A side and your B side, it means at this point, we can call it x1, at this point x2. So to get this length, it's x2 minus x1, which is basically what we have here, and your y, you can say y1 and y2. So in other words, to get this height, you say y2 minus y1 to get the b side, okay, which is this one. So when we're applying that formula now, here, right, it's x2 minus x1 squared plus y2 minus y1 squared is equals to c squared, right? But you know that your c squared is ab, so it's ab squared. So you get the square root both sides, then it becomes, so here I'm just showing you the basics. I hope we agree. So that's how you arrive at this formula. So it's just a basic application of this. So solving it, as you can see, we know that our y2 is 5 minus y1 is 2, so it will give you 3. Then here your x2 is 5 minus 1, it gives you 4. So which means when you apply this formula, it becomes, this is where we are, 4 squared plus 3 squared. So basically it will become 4 squared is 16 plus 3 squared, which is 9. You get 25. Then it becomes square root of 25. That's why we are getting 5. So that's pretty much it. That's pretty much it. So just to go through this, so just revising. So substitute both coordinates carefully into this equation. Then square, then the x difference and the y difference. That's what we did. Then add, then take the square root. Then the distance is always positive. So you know that square root gives you plus or minus, but since it's distance, we focus on the positive only, because we are dealing with distance. So once you understand that, then you can understand how we got to this answer. So let's move on. So midpoint of a line segment. So the midpoint is exactly halfway. It's exactly halfway between the two endpoints. So going back